Welcome, everyone. Thank you so much for joining us on our session around improving iteration in geo-distributed scenarios. And special hello to everybody on the live stream today. We're so excited to be here. I'm Grace. I'm one of the senior product managers on the Unreal Engine team. And with me today, I have Joachim, who's one of our senior programmers, also on the Unreal Engine team, as well as Phil, TD from the Coalition. Here's a brief overview of some of the topics we're going to cover in our talk today. So between making UE4 to UE5, we noticed some trends in how game development was changing. On one end, we saw that projects were getting bigger, so that's not only in the number of assets that were coming in, also the quality of the assets that were coming in. Then there was a set of challenges with this. It was taking people more time to sync to these projects. Your team members were often running out of disk drive space and having to make hard decisions. If you had multiple work streams going, maybe like a feature branch, and you also had maybe a release branch, you would get to a point where you were almost out of space and might have to unsync an entire workspace to make room for another one. And this was very wasteful. On the other side too, we also saw that teams were getting more distributed. So we had studios spinning up in multiple locations with people sometimes working from home or fully working from home. And of course, when the pandemic hit, we all turned into remote workers overnight. So we too saw some of these challenges with the projects that we had here over at Epic. There was no easy way to share work that you were doing amongst your other team members. So things like cooking content and having really good access to shared network caches, that wasn't really working very well anymore. So with UE5, we really sought out to fix some of these things and address them. On the side of projects getting bigger, we really want to find a way to allow people to sync to projects with much smaller data syncs so they could get that done faster. And on the part of people getting more distributed and having people working from home, we really want to ensure that regardless of where you were, that you would have a really good experience, whether you were working from home or in an office, and to be able to leverage the work of people around you. Part of my role as a product manager is I'm here for everyone in this room. I'm here to connect with you, to hear your feedback about what's working, what challenges you have, and bring that back to our dev team so that we could really make a roadmap that will address a lot of these things. So here I've put a little sampling of some of the feedback I've heard when I was engaging with licensees and asking them what their challenges were, what they were thinking about their data sizes. Very unofficial poll here, but we also asked a few years out, where do you think your team members will be working? Are they going to be in the office, a blend of the two, or fully from home? And you can see here, it's very unofficial, but I think what we've seen is that hybrid and work from home is here to stay. So any investment we put into this space is really going to help take us forward into the future. So on the problem of projects getting bigger, what can we do about sync times? So we talked about some of the challenges that we're facing here. What we're introducing is something we're calling virtual assets. What you can think of this as is it's an opt-in feature that you could choose to take on for your projects. We're taking U assets, which traditionally have kind of multiple parts of data in them, and we're splitting that up into two pieces. The first piece is going to be the structured data piece, which is kind of that core metadata. It's usually quite small, and these are the things that the editor needs to represent that data. So you could think of things like thumbnails, properties that you would see in the editor. And the point with virtual assets is most of your team will ever only need to sync to this very small piece, and probably nothing more than that. The part that we defer syncing on is what we're calling kind of that bulk unstructured data. This is the part that generally is things like you can think of as pixel data, or if you're working with sound assets, it would be things like .wav files. And we essentially don't sync to this unless if you actually need to update that bulk data. That's the only time that you'll actually retrieve it. So that's about virtual assets. And the other thing to mention that's a benefit of this is we reference that bulk data through a hash key that's of the contents of the bulk data. So that means if you have multiple work streams and you have that same use asset that's appearing in multiple places unchanged, you're not going to collect up multiple copies of that. It'll just be that one. So on the problem we had of teams getting more distributed, in the UE4 model, this is kind of what we had roughly. So you would have a studio somewhere, you'd set up a network drive probably, and share your cooked content amongst those team members. If you had another studio spin up somewhere else, they too would then have their own network share with also that DDC access there. And if you had somebody working from home, unfortunately, although they could connect to one of those network shares, depending on how far they were and how good their network connection was, this wasn't great, and it was probably slower than if you built actually and cooked the content yourself. So that was not efficient. So the way that we're going to address this is we're releasing something we're calling the Unreal Cloud DDC. And I'll walk through this a little bit. So the way that it works is you're able to set up these cloud regions, kind of nodes that are closest to where your team members are. And it allows anyone working from anywhere, even if you're working from home, to have a really quick connection to your DDC. So what happens is if you're working fully from home, you'll find a region that's closest to you. That's where you could retrieve and also push up content for the rest of your team to share from. And that gets auto-replicated between the regions, kind of behind the scenes. So if you're somewhere over in Europe, you're doing some work there, eventually someone over in North America will be able to access that. A few things to kind of point out with this system is this too also benefits from this kind of deduplication of data that we're talking about, because our DDC content is also referenced through a hash of the contents itself. You're also not carrying multiple copies of that content. Also, if you're still in a studio, you're probably going to have a faster connection probably to your network drive, so this doesn't take away any of that. You could still leverage that first before then looking through to the Unreal Cloud DDC for content. So piecing it together, what does this look like when all of these pieces are working together? So here's a little example of a workflow. As a user, you would first sync up, let's say, to an asset. So again, you're syncing to a very small piece of that metadata we talked about, so this would be very quick. Next, let's say if you want to preview your project, you want to run it and see what the game looks like, you would then attempt to cook this asset. At this point, you're going to try really hard to not have to do any work locally, so you're going to do a series of lookups. And we like to order these caches. You can configure them, but they're going to go from fastest access cache to slowest. So first, you're going to look locally to see if you have that available already. If you don't, you're going to then go to your Office DDC, and then from there, then fall back to the UE Cloud DDC. So something to note here is that we do a test on kind of trying to access these caches. So if you have a worker who's sometimes at home, sometimes in the office, and they're at office for that, or at home for that day, when they go to look for things in the Office DDC, our code's going to realize that you don't have a good connection speed there, and then it's going to skip past that and go up. From there, let's just say you've seen the game, you want to make some updates. Maybe you want to make that island a different tint of green. You would then proceed to check out the asset like you normally would, and then from there make the updates that you want to. At that point, you're going to go and attempt to cook that asset to get it ready for your target platforms. So at this point in time, this is where you need the bulk data that's coming in, because you're actually manipulating and updating kind of what the asset looks like. And we do something very similar here. You have a series of caches where you're going to go and look for that bulk data, starting with the local one and then working your way through to the Office DDC, the Unreal Cloud DDC, and really noting here that in most use cases, if you have an active project with an active team working on it, you're going to have a pretty warm to hot cache. So this will actually be most of the use cases. You should be able to find content and bulk data through this series of caches. But as a last fallback, your data will always be stored in your source control, something like Perforce. So if that bulk data is not there, you would then actually go to Perforce and retrieve that. From there, now because you've actually made updates to the content, you're going to actually cook that. And once that is done, if you're happy with, let's say, what's there, when you go to the commit step, you're going to push that bulk data that you made updates to back into source control, and then also back through, kind of in the background, it'll get submitted back through those series of caches so that it can be shared with the rest of the team. So quick recap, I think we get the question a lot, like what should we actually use? Should our team, take this? So we have some notes here just around kind of the statuses of these pieces of tech and when you'd want to deploy them. So for virtual assets, this is coming in beta status for 5.1. That means that we've actually turned it on internally on projects here at Epic, and we're quite happy with the results, and it's ready for, I think, users and teams who want to try to dabble in this to turn it on and see how it could work for you. With our Unreal Cloud DDC solution, we're putting this at experimental status for 5.1, which means if you're interested in having a look at it, experimenting and trying it out for your projects, you're free to go ahead and do that, and we have some light README notes for that. So some scenarios to help you decide whether or not you want to turn this on. On one end of the side here, we have scenario one, which is if you have a very small project, you have small assets, not a lot of people working on, something. These solutions are probably a little bit too much overhead for your project to have it all set up and some of the infrastructure you would need to get going. In that case, we probably recommend getting the best hardware you can and then looking in other areas to improve developer workflows. On the other hand, kind of between scenarios 2 and 3, this is where you get into places where some of your asset sizes might be getting bigger. So maybe you have a small team working in one studio and you're starting to use Nanite and really generating larger assets. In that case, we think if you're all in one studio, having the Cloud DDC wouldn't be as helpful. The network share probably would do a really good job there. But virtual assets in that case would help users on your team get smaller data sinks. And then moving on, if you have then team members that are distributed across different locations and some people working from home for sure and in hybrid scenarios, Cloud DDC, Unreal Cloud DDC is what we would recommend there, but you might not have to turn on virtual assets if you think your data size is quite small and the assets are small. And then lastly here, if you have multiple studios going, work from home, and really big projects with lots of assets, you'll probably want to turn both of these on together. So with that, I'm going to pass it off to Phil, who's going to tell us a little bit about the coalition journey.
Perfect. Thank you, Grace. Hey everybody, so yeah, I'm going to go through a bit of a case study here at the Coalition. I'm going to give you a brief background of what the Coalition is and who we are. Go through a bit of a history of kind of some of the development we did on Gears 5 to kind of really set the scene and the context around why we were so excited to kind of see this technology come online from Epic around virtual assets and the Cloud DDC, and then go through some results actually of us actually adopting it, running it in the studio right now, and kind of share that with you folks today. So, brief intro about me. I'm Phil. This is Debbie, our basset hound. I like this picture. When they asked me for a picture, I like this one because it's got our dog in it, which is cool. I'm the engine technical director at the Coalition. I've worked at Xbox for over 15 years. At 3 different game studios. And I've got about 10 years of kind of professional experience with Unreal, mainly around UE4 and now UE5, a bit of UE2 back in the day. So who are we at the Coalition? So we are a Microsoft first-party development studio located in Vancouver, Canada. We're the official home of the Gears of War franchise, you probably know this. And our objective is really to forge the future of the IP and to push the limits of Microsoft's entertainment platforms and devices. And our team is comprised of like a deep creative set of folks, of lots of technical talent. And we really just basically cohesively try to pull all these great talent together to really delight our customers and really surpass our expectations of what it is to make a game like Gears of War. So developing with Unreal, so looking back, like we have a long history of using Unreal as a studio. We've shipped a lot of titles like Gears Ultimate, Gears 4, Gears 5, Gears Tactics. And we have, like, say, a deep knowledge of using UE4 and now into UE5. We have just generally the way that we work, we've always engaged with external partners to kind of augment the talent that we have at our studio. So we're kind of very akin to kind of like how do we get Unreal to work outside of our studio. And because of this, our engine team that I manage are really good at kind of making our tools and workflows work with external partners. And that kind of sets the ground for a lot of the stuff we're going to talk about today. But however, like most of us, I think these things work very good when you're on-prem on the main site. And they always kind of work best in that scenario, regardless of like how hard we try to kind of make these things work for our external partners. So going kind of through to Gears 5 development, again, just to set some context here. So the Coalition roughly had about 350 people on-prem up in Vancouver, and we worked with roughly 12 external partners all around the world, like basically any time zone you can think of, we covered quite a few of them. We're definitely, from what Grace talked about, we're definitely a Scenario 4 studio. We have a lot of folks working on the project. We probably had about roughly 1,500 people in total working on Gears 5 over the full course of development. We had massive content sizes. Going through some stats here, which are really interesting. We had roughly 23 terabytes of raw content per branch, which is kind of insane. We're talking things like PSDs, ZBrush files, FBXs, a lot of stuff that goes in there. Our content folder was about 2.1 terabytes on disk. And we also then had a lot of branches. Obviously, when you're shipping a AAA game, you're going to have your dev branches, your release branches, your going into cert, your retail branches, things like that. We did that for a lot of our release pipeline and a lot of hardening branches as well as we went through development. We created a lot of branches for things like title updates or DLC, again, just to isolate the team to make sure that we can kind of do this work and not affect the folks who are working in things like the main branch. And then, when we did things like major system overhauls, again, we branched again, and thinking about these like content sizes and these raw sizes, all of this was duplicated essentially on disk when people had to go and sync one of those branches. And then looking at kind of our infrastructure, I know it's a little small, I apologize, but what we did on Gears 5 is we actually didn't have a really good way of distributing content sorry, we didn't have a good way of distributing all of our information to our partners. So we actually used Perforce as our primary way of getting information to our partners. So they didn't necessarily just always take things like code and content from Perforce. We actually put all of our tooling in there, all of our things they would have to use from a day-to-day basis. And we even did weird things like take P4 labels and augment them with special information so that our primary external partners could really just use Perforce for lots of different things to basically make it as smooth as possible when they're working with us. So I'm going to say a good picture of kind of how geo-distributed we were. And this is kind of just a sneak peek of kind of how our infrastructure was set up internally. Like most of you probably have like an internal network if you're using Unreal. We had our internal users on a really fast network connecting to things like our P4 server, applications and services, building compute farms and things like that. And then for our external partners, unfortunately, the only path they had to get access to some of this information was through a P4 broker and a P4 proxy that they set up locally. So again, if you're on site, you had this amazing network with all this amazing content that you could use and services. And then for our partners, they really only had this one route to kind of get into, to get access to our data. So. And then kind of like digging down a little bit further. So what this meant was that if a partner really wanted to work with us and have a good setup, they basically had to duplicate a lot of the same infrastructure that we set up locally, which was okay, but it did cause a few problems. So this is an example like at the Coalition. We had our main Perforce server. We actually introduced something called Signiant, which is actually like a file share replication system, which helped a little bit to kind of take a little bit of pressure off Perforce. But it meant that a lot of our external partners had to set up things like local compute for shader compiling, derived data cache equivalent, and their proxies and things like that. And then we tried to shuttle as much information as we could over to their site to really just keep them up and running and reduce the amount of local infrastructure that they actually needed to set up themselves. But as you might imagine, this actually caused a lot of pain points for us and our partners. The biggest one that we found that was an issue for them was access to compute and a hot DDC. So you think of an example like one of your rendering engineers or maybe one of your tech artists goes through and makes a change to your base shader. That's going to cause a lot of shader compiles across the board. And what would happen is that we would submit that back to Perforce, and if we couldn't get our partners a hot DDC, they'd spend a lot of time locally basically computing the same information again and again. So that was definitely a pain point for a lot of our partners, and it caused a lot of slowdowns. Another one, obviously, we looked at our disk size or our branch sizes. Disk space was an issue for a lot of people. Like, Unreal works very well if you're on an SSD or an NVMe drive, but when we started kind of bleeding into multiple branches, we had to actually write our own little tool. We called it Mr. Junction. They don't let me name things anymore because that's an awful name. But basically, to junction all your content across multiple drives purely because our branch sizes were so large. And a lot of our partners really had to kind of fall back to spinning disks, which again is not ideal with Unreal. We had a lot of problems with geolocation, so like the time zone differences, and actually people setting up their own infrastructure locally really meant it was quite difficult for my team to actually support them. So we didn't really know, like, did they have a hot DDC? Did they have like local compute working? And we had to spend a lot of time diagnosing these issues, which again, because we couldn't control or own that stuff, it was definitely a problem. And then bandwidth, obviously we were submitting a lot of content. Sometimes we'd submit terabytes of content a day, and I think the worst I saw was about 500 gigs an hour. And so, they were syncing down a lot of content just to work, and as we probably all aware, things like code data dependencies on Unreal are a problem, and if you don't have the latest code and content, sometimes it's very, very difficult to actually work with the editor, and it can cause things like crashing. So, it definitely was an issue for a lot of our partners. It's not all doom and gloom, I get it. Like, we did actually ship a lot of good games using these workflows, but we definitely, had to manage a lot of very unique setups outside the studio, and it's something that we were very, very cognizant of and try to constantly keep improving. So, and then the pandemic hit, like most of us. It definitely threw a lot of spanners in the works there. So it really did change how we thought about development when that hit, and I'm sure a lot of you folks have similar stories. Basically, we started dealing with not just the external partners, but now a lot of remote workers, where traditionally everyone would come in the office, would have all this access to great stuff, and that changed overnight, essentially. Some challenges were very similar, like you've got an external partner that needs access to stuff. So a lot of the infrastructure that we built initially for external partners worked, but a lot of new things came up. The idea of having a partner of a certain size with access to local compute is awesome, but then when you've got lots of individuals who are just one person at home, it's very, very different. You can't just replicate all that infrastructure for every single person at home is what we found. It's very expensive and doesn't work very well. But it definitely gave us a good appreciation of things and workflows that didn't scale and didn't work very well when we were offsite. And yeah, I kind of covered this already, but yeah, remote workers have wanted just very different challenges compared to, say, external partner studios. And then, like most people, I think, in the room, we scrambled to try to find solutions to these problems. We did very naive approaches when we first started. We did things like, hey, you get access to a VPN and just remote desktop into your machine on site. Kind of works for very simple solutions. But then what we found is that things like very, very latency-sensitive workflows, like art workflows, or using things like My Emotion Builder, using the editor, people really didn't like that. So we actually started to move a lot of more resources into the cloud so people could work on local workstations at home. And our mantra is always that everyone needs to be as effective as possible, regardless of where they are. So kind of bringing us forward a little bit to transition to UE5, we've actually transitioned to UE5 for our next project. I'm sure there's lots of great talks here at the conference, but there's been a lot of great improvements to the engine, assets, workflows, fidelity, all that kind of great stuff is there. The little example I have here is like this is built out geometry, which you wouldn't have done this before, this little picture from one of our artists. But what we found is actually a lot of the similar workflow problems that we faced with in terms of the DDC, et cetera, still remained actually when we first took on UE5. So, and if we all look, like, the content fidelity and asset sizes have actually got a lot bigger. If you look at things like nanite, things like textures, they're getting larger, which is actually going to exacerbate some of these problems. So we were super excited when we heard about virtual assets in the Unreal Cloud DDC, and you could see what challenges these could solve for us, or what problems you could solve for us, sorry. So going through a little bit of our adoption of virtual assets now and kind of what we found. So we had some success criteria we wanted to look at based on some of the stuff that Grace has already talked about. So we really wanted to reduce the amount of time the team spent syncing every day. It's just a classic thing we all hit. We wanted to see these savings scale over multiple branches. We had a lot of problems where people would just duplicate branches. We did do things like per-force stream switching, which does help, but it's definitely not something which is traditionally done at our studio. And we really wanted to reduce the overall disk size requirement for both users and build machines. We have a lot of branches. It's something that just kind of doesn't scale out very well for us. So, and we really wanted it to be not noticeable when people were working with assets. Like if it had a massive delay or lags, et cetera, it's probably not going to be good for people's workflows. So looking at the setup, it was great that we kind of went through, and it's really easy to set up and store the bulk data in both Perforce and in the Cloud DDC, which was great when we kind of had this set up. What we've done, we've actually kind of split our payloads where you store them in Perforce in a different directory or a different stream to where users sync every day. You don't want people syncing to that stuff as their traditional normal syncing. And then you need to make sure that when you set this stuff up, that everyone has permissions to submit the data back into Perforce, regardless of where you pick to put it. And it's we store our bulk data in virtual assets with our setup. It's per project for us, but you could actually push it higher in Perforce to actually increase the amount of G-duplication that you have. Because if you have multiple branches and all they'll point to the same data, then it's obviously deduplicated across all of those branches, which is really exciting. And it does require at the moment that the Unreal Editor has a valid Perforce connection just so it can go and find Perforce as a backup, or that bulk data as a backup and submit it back. And then, as it might make sense, you need to make sure that your payloads are submitted to Perforce before the virtualized assets are put in, so that if someone does sync down a virtual asset and needs to get the bulk data, it's there for them to get. So looking at the rollout, we did it in 2 phases. We did a bit of testing just to make sure. I know Epic themselves have been using it, which is awesome, but we wanted to make sure that it kind of worked for us. So we tested this in isolation in a branch with both the textures, which is officially supported, and with static meshes as well, which I know aren't officially supported, but we're just curious because our project's got a lot of nanites in it now. We really want to see how it worked. So basically, to roll it out, we basically went through and we saved all our packages, so it actually splits the asset into the bulk data payload portion and the metadata portion that Grace alluded to earlier. And then there's a great little tool, actually, that's in Unreal, which is called the Unreal Virtualization tool that basically can give you the ability to run virtualized and devirtualized content in an unintended manner. And then we went through and we basically picked folders one at a time and basically virtualized textures just to kind of see how it works. And then what we did as well for our users to start with is actually disable virtualization on submit, just to kind of make sure everything was working as intended. And then we're very metrics-driven at the coalition, so we actually made sure that everything was working. Before then, we extended this to go a little bit further across more and more folders in our project. And then personally for us, we're actually integrating the virtualization into our local validation tooling so that when people do a validation locally on their content, it will then virtualize the asset and then submit it back for them. And because we're metrics-driven, we was actually tracking every single, this is just one asset that we had, making sure that everything was actually working intended and that people could pull and push the payloads when they were working with virtual assets. So the bit you've all been waiting for, I think the results. So we're actually seeing a typical file size once things have been virtualized down to like 0.1 megabytes, which is impressive. We have some skybox textures and things like that, which are 300 or 400 megabytes, but they reduce down to this size, which is like 0.15% of the original size. Hydration hasn't been noticeable, which is great. So when you need to get that bulk data back, it's been pretty fast for people, which is awesome. And we're super excited by the savings. So this is our current project that we have. And we actually had a disk saving of about 38 gigabytes to start with. We use a lot of nanite, so we're very excited for that to come online. But it's definitely something that has been a huge improvement. And then going forwards, actually projecting back to Gears 5, we would have probably saved about 690 gigabytes of disk space, probably higher. We actually have our own material masking solution, which stores a bunch of textures. So if it could have supported that as well, it's probably somewhere in the region of probably like maybe even 80% of our disk footprint would have been virtualized away, which is pretty exciting. And again, we couldn't imagine the total sync times we would have saved over the course of all the branches and all the projects. It's just something we couldn't calculate, but it would have been huge. And we're very much looking forward to the other asset types that can be supported in the future with this solution. And then just last piece of information, we found that textures are super low churn for our project. About 50% of our textures only ever had one revision. So imagine you're syncing this all the time, but they never change. And then 74% of our textures only had like 2 revisions. So again, super low churn rate, a lot of savings there to be had. So moving on now to the Cloud DDC adoption we went through. Similarly, we looked at some success criteria for adopting this technology. So we really wanted to make sure that we could improve developer efficiency with Unreal when they were working outside of the office. Obviously, inside the office, it's great, but outside has been definitely a problem for us. We really wanted to also reduce the need for that local compute we talked about earlier. We really didn't want our partners having to have big compute farms just to support things like shader compiles and things like that. And we also wanted to reduce our reliance on a VPN. We really didn't like the fact that people had to connect through a VPN because ours is quite slow and causes quite a lot of problems for us. And we also wanted to deprecate some of our old tooling. We had this really janky DDC replication solution we had with zip files. We really wanted to get rid of that if this solution was good. So going through a bit of the setup, this is kind of exciting. When we say we collaborate with Epic to stand this technology up in Azure. Traditionally, Epic are running this in AWS, but it's kind of great to do a collaboration and partnership with them. It did require dedicated engineers on our side with knowledge of Unreal, of cloud-based infrastructure, and definitely authentication, because this is public internet-facing for how we've set this up. And we, I think Grace alluded to earlier, we've defined a backend graph which points to the cloud and to a file share DDC. So it basically tries to connect each one of those, finds the fastest, and goes and uses that one. And the choice is made based on things like accessibility and latency. So it does, and from what we found, I think 99% of the time, it does pick the right graph, so users do get the best experience. And Microsoft is actually looking to create a marketplace offering for Azure users. So if you're interested, there's a QR code, there's a blog to follow, and we're trying to make this as turnkey as possible so folks can just stand this up and use this out of the box, which is awesome. So then looking at the rollout again, we did this in 2 phases. So during testing, we started in a separate P4 branch and fully tested the Azure infrastructure that we built to kind of make this work. We brought in several users to test, especially in those in remote locations. We were very fortunate that we've got teams that work remotely, and we tried kind of all over the world just to kind of people to kind of hit the solution and see how it worked for them. And then we did some testing around things like asking users to run with like hot and cold caches with both a VPN connection and with the Cloud DDC enabled to see how that worked. And then we gathered a lot of stats. We say we're very stats-driven at the coalition. We like gathering data just to see how it was working for them. And then once we gathered all those stats and we were happy with what we were seeing, we went through the rollout phase where We basically applied this as an opt-in test in our mainline branch. We then monitored users as they enabled it, just again to see that everything was working, no one was actually experiencing any problems. And then based on what we're seeing, the system is definitely picking the right DDC based on access and latency, which is great. And we've currently rolled this out to 2 data centers replication enabled, which is great. So that all that infrastructure is set up and running like Grace showed earlier. And I know this is very small, I apologize, but yeah, we track all of our stats internally, and really just wanted to make sure like how many times people are being like prompted for things like authentication, making sure they are hitting the right DDC based on where they are, if they're on-prem and on the local network versus at home and hitting the Cloud DDC, and the results have been great for that. So getting to the actual results then from what people were seeing. So based on editor startup with clean local caches, we're finding that the cloud-based DDC is actually 2 times faster than accessing the file share through a VPN, which is amazing. Like that's definitely a huge win for us. And then, like you might expect, we did try this, but it's actually 2 times slower with Cloud DDC than accessing the file share if you're on-prem. But again, you're on the fast network, you can connect to the SMB share. That's expected. We just wanted to make sure that everything was working, and we got the results we expected. We didn't compare the editor without using any shared cache, because as we all know, that's probably pretty terrible. You're going to be compiling shaders and just waiting a lot. So we didn't bother testing that. And then we also found that cooking showed very, very similar speedups, which is great. And the good thing for this is that it kind of just works for everybody. Like once we'd set this up and then we had the ability to connect with this graph back to the Unreal Cloud DDC, it just kind of was very, very turnkey for people, especially compared to our old solutions where people had to do things like copy a zip from a location. We had a few tools around it, but it basically just made it very, very simple for that setup, which was a huge problem in the past, especially working with external partners. And looking at it now, like the costs for us, it's about $31 per user per month for the 2 data centers that we run at the moment. And this is my favorite quote that I got from somebody randomly. Again, we don't usually do just people sending us quotes, but somebody found that their cook time came from 2.5 hours to 30 minutes based on connecting to this solution. So these are the great kind of comments we've been seeing and hearing from our users as they've been using this stuff. So just to wrap up, a few key takeaways. It definitely really has helped improve our remote working experience, which is great to see. It's reduced our sync times and bandwidth requirements based on virtualizing content. It really has lowered that need for local compute. People no longer have to do this. They can actually just access all of that stuff up in the Cloud DDC. And overall, it's reduced our disk requirements across all the branches that we have. And as we grow, it's going to be definitely seen even more. And it's a native solution to the engine, which is awesome. We had a lot of custom solutions in the past to try to solve this, and it's just great that it's just there. And it feels great, like we're engineers. We love removing legacy and old stuff. So we actually got to remove a lot of stuff we had at the coalition just to kind of support our old workflows. And then one of our takeaways was that we would suggest if you were going to do this, like to set up the Unreal Cloud DDC first, because it makes setting up the virtualized assets much easier, and you can use the Cloud DDC as this payload option as well. And this works due to how globally distributed we are. It's just one, we are definitely a scenario 4. We've got a lot of people around the world, and it definitely works for us because of the number of people we have connecting to this stuff. So with that, I will hand it over to Joachim, who's going to give you a breakdown of the Unreal Cloud DDC.
Right. Hey, everyone. So I'm going to go into some more technical details about how Unreal Cloud DDC works. So Unreal Cloud DDC is actually a generic structured storage system. So it's not built specifically for DDC, but that's what we primarily use it for at Epic. So what I mean by that is, with the structured part, is that we work on key value objects that we call compact binary objects. So think of them like a JSON object. But they it's a better binary, more efficient binary representation of it, and a richer typing system as well. So a couple of features added on that kind of. One of these types that we've added is called an attachment, which lets you reference a payload by its hash, so it's content addressed, which means you get like a structured object of a key value, and then that's a reference to a big thing, like a texture or a mesh or something like that. And these things are stored in a content addressed store, meaning they're addressed by the hash of the content as well. So we get a natural deduplication there, where we only need to store the payload once. Content addressable store is also super valuable from a replication perspective because we can quickly determine that we already have this object, don't need to replicate it again. Another feature that we do need when you're working with DDC specifically is a general mapping from key to value, because you need to map from the DDC key to the output object. So that's also a feature that we do have. We map it via a hash to the output object. We also have something which we call namespaces, which essentially allows you to do multi-tenancy. So you can set up Unreal Cloud DDC once for your entire studio and have multiple projects in it. So the namespace lets you control access, so different users have access to different parts. And then we have a feature called storage pools that lets you configure how the deduplication storage works in relation to the namespaces. So you can configure it in a way where every project writes to the same storage pool, so same S3 bucket, and then you get full deduplication across all of your different projects. Or if you're more concerned about that, you could also set it up so that each project writes to its own S3 bucket. Maybe you want to do that for billing reasons or something like that, which you can also do. So you have full flexibility in terms of how you want to sort of weigh those two things. And then as we're writing this, like this is a lot of data that goes into the system, a lot of churn in the DDC. So we have built-in garbage collection as well, so it will automatically remove objects that haven't been used for a long while. We do this by doing lost access tracking. So whenever someone accesses the cache key, we just store that that's been accessed, and then we can delete that when an object hasn't been accessed for a certain period of time. We run 30 days as our sort of how long we keep it around, but that's configurable. You can do whatever you want. So let's have a look at the architecture here. So you can see the Unreal Engine there on the bottom left. That's like the editor or the cooker, something like that, that connects to the DDC. It will connect using HTTPS to our web API, so that's the source code. That is like the Unreal Cloud DDC. And that has a few components that it needs. First off, it needs a database to store the reference mapping, essentially. So it stores a really small payload that is just essentially like information about what else exists. For that, we use Scylla, which is a Cassandra-compatible database. It's essentially a rewrite of Cassandra in a more efficient way. It's super, super performant and supports global replication as well. So it's super good. And then outside of having to set up Scylla, it's actually good to mention that Scylla can be a bit of a hassle because it's Linux only. So you kind of have to set that up. There's some good resources available from them to set it up on your cloud providers. They have a managed offering as well if you want to use that. We use the open source version, which is free. So that's great as well, no licensing cost, but it is a bit more effort to manage that. So then we have the shared storage, which is where all the blobs go. So that's the blob storage. This gets really, really large. I think ours is 40, 50 terabytes or something like that right now. So that's an S3 bucket for us on AWS. We also support Azure Blob Storage, so that's what the Coalition guys use. This is a super simple part. It's not a lot of code, so it's easy to add more if you have some particular type of storage that you want to use. We can also just write it to a file system if you have a need for that, say you're on-prem or something like that. But it is a problem that you need something that has elasticity so that you can grow. You don't want to run out of disk space there. Anyway, that's what we use. We use S3 for that. The problem with S3 is that it's not particularly performant. Like it's quite slow to fetch stuff from it. So we need to cache stuff in front of it. So we have a local cache in front of S3, which is essentially an NVMe drive attached to every web API server. For us, that's about a 7 terabyte storage per machine, which gives us essentially our entire working set for most of the week is like live data on an NVMe cache that we can serve directly. So that's quite performant. And that's one thing to note about DDC workload in general. It's very latency sensitive, partially because of how the editor works, where you need to retrieve data quickly to figure out if you should be cooking or not. So it's sort of like, yeah, you do kind of need to be thinking about latency here. That goes into the whole idea of geo-replication and how it's set up as well. You kind of want a decent distribution of nodes so that it's not too far away from users. Anyway, the other thing I wanted to mention here on this slide, you can see region B down there on the lower right. The point there is to show that this is, you have the same infrastructure in every region. So you get like a full copy in every region, kind of. And then in the middle, you can see the auth setup, which I'm going to talk a bit more about next. So the idea here is we run Unreal Cloud DDC on public internet. we avoid VPN. And the reason for that is there's multiple reasons. VPN tends to introduce complicated routing, which increases the latency and is typically a problem. But also bandwidth issues can be a concern. And it's just generally annoying for users to have to be on like the VPN. So we run this on public internet, which means we need to secure it. So what we do is we hook it up to OIDC, OpenID Connect. So you can hook it up to any identity provider you might have. Your single sign-on system, your Azure AD, Okta, whatever you use. So for us, what happens is the editor will support interactive login. It uses auth code with Pixie. So users will essentially get prompted with their normal Okta login, type in your password, do your multi-factor thing, and that will log you in. We do also support client credentials if you don't want to have an interactive login, but that's not as secure. And we can also disable all of this if you want to. If you're on-prem or something, you trust your network. It's probably not a good idea to do that, but you can for development purposes, if nothing else. And the last thing to note, so everything is referenced by hash, right? So you need to know the cache key to be able to fetch content. That gives some level of security because there's an obfuscation layer there. But we also made sure that there are no endpoints that allows you to enumerate the content, meaning you would actually really need to know the content on top of having the token to be able to even access these things, which also gives some layer of security on top of what you would normally get. Right, so talking about the deployment at Epic then. You can see here I color-coded like a distribution of where we have users. So you can see we're kind of heavily on the North American side. So we have 2 regions there, one on the East Coast, one on the West Coast. Then we have 1 deployment in Europe, 1 deployment in Korea, and then 1 deployment in Australia as well. So we have about 1,000 machines hitting this every day. And the total cost for us ends up being about $35 per user per month. And that is not the most fair way of calculating this because the region in Australia is much more expensive, per user because we have fewer users there. It's like a fairly high base cost, about $3,000 per region for us, and then the more users you have there. So there is a bit of a trade-off between number of users and performance. And the primary reason it works like that is because of the fact that we want this like MME caches and full copy of S3 and so on, right? So and we actually have like lots of redundancy for each region as well, like multiple copies of everything. So we've definitely tended more towards availability and performance rather than cost in this case. So if you wanted to, you might be able to push this down to a lower cost if that was a priority. But anyway, so yeah, 5 regions. We serve 40 million cache key lookups a day, and there's more web requests than that. That's just the cache key lookup itself, and then a few other things happen. And for us, we store about 30 terabytes right now. And it's interesting to see like how the deduplication ends up as well. We have certain cases where we have 30, 40, 50 copies of the same cache key being only stored once. And in like a setup where we're storing this by the DDC cache key, you would have ended up duplicating this 50 times, right? So the content addressable store does really help a bit in terms of deduplicating efforts. Right, so I'm just going to quickly talk about how the replication works as well, because this tends to be what we get the most questions of. So there's essentially 2 phases to the replication. First off, when you write something into Scylla, so you write a new ref, Scylla will replicate that. That part is super small. It's 150 bytes or something like that, I think. So that gets replicated pretty much instantaneously, within a second, everywhere across the world. So that you will know immediately that the cache key has been written, but you won't have the actual payloads. You won't have access to the texture, right? So the texture or mesh or whatever you're adding, that is managed by the blob replication, which is a built-in feature in Unreal Cloud DDC. So we do that ourselves. And the reason we do that is so that we can have a bit more control over exactly how the replication happens. The blob replication, there's 2 ways that can happen. There's an on-demand mode and a speculative mode. The on-demand mode essentially means if I'm connecting in Sydney, trying to fetch the texture, it doesn't exist, it will connect to US East 1 where it existed, pull it down, and then serve it to the user. It's super slow, it's not particularly good, but it leads to a view, like a consistent view in terms of which blobs exist. We don't really use that for DDC. It exists mostly for other use cases that we are not talking about today, but it's good to know that it exists. The mode that we do use for DDC is the speculative replication. So that is essentially building a journal of all the ref keys that gets added in one region as they go. And then every other region will just read this journal, assume that it needs all of those things, and replicate all of them. And that's per namespace, so you can configure if certain namespaces are replicated or not. But other than that, it's just going to try and pull down everything, assuming that you need everything. And this journal is only 2 weeks worth of data. Typically, when you have the DDC data, the data that got added at the beginning of time, 6 months ago, 2 years ago, that's not necessarily interesting anymore. So we only keep a small part of it around, and that's the data that we replicate. The good thing about DDC is if there's ever a cache miss locally, the worst case is people will just build it locally, upload it to the DDC, and since it's content addressed, it's the same result as if we'd replicated this. So it's still consistent everywhere. So worst case, users just end up building it locally, which is a case we want to avoid, but it's not a catastrophe. Right, thank you. I'm going to leave it over to Grace to talk about our roadmaps.
Awesome. So as a product manager, I love roadmaps. This is my most exciting part of the presentation. I hope everyone's excited too. So a little bit of a preview of what's coming. So for 5.1, we said virtual assets is coming in beta status. That means it's ready for you to start turning on and trying on in your projects. Currently for source control, we support Perforce. And out of the box, we support textures and audio asset types, with more to come in the future. Right now, we also have a few different ways that you could turn on virtual assets. You could choose to, let's say, maybe set certain packages where you opt in or opt out certain things to try that out first. Or you could actually go and select an asset type and say, maybe I just want textures for my entire project to be virtualized. That could be a route you take as well. We also have a feature where you can configure the min size for what would be considered a candidate for virtualization. For us, we found that 0.5 meg roughly is kind of a really good benchmark that kind of weighs file sizes that aren't too small. And that lets us virtualize about 30% or so of some of the assets that we ran through for internal projects, and that worked well. The other thing we have too is we have the option for you to de-virtualize, or what we call rehydrate, after you've virtualized a project. So this is normally useful if you actually ship samples, let's say, to end users. You'll want to stitch back everything you virtualized into kind of whole new assets. That's going to be ready for 5.1. We will have this mentioned in more details in the release notes as well. We're looking to push out a dev blog, so definitely check that out. So next on our radar, we've heard Nanite come out a few times now. That's definitely on our radar, something we're working on in progress. The other thing that's really big as well for us is we want to work on something we're calling work offline mode. We alluded to the fact that you actually need an active Perforce connection for being able to retrieve things like bulk data. And what work offline mode will enable you to do is if you have a scenario where you know you're going to have a bad network connection, let's say you're traveling somewhere, but you want to be able to do some work, you could actually opt to sync ahead of time and kind of get the bulk data that you need. So that's what we're working on next. Other things that are further down the line, but under consideration, we're looking at other source control support. This is where your feedback's really valuable to us. I'm here to hear kind of your needs where everyone else is. As an example, we think Git might be next on our target down the road. Also, other asset type support. So we really started off with the high ROI asset types where we knew people had lots of these types and wanted to kind of tackle them. There are other things like skeletal meshes and beyond. So definitely, if your project has asset types that aren't listed on this list and you want to flag that to us, please come find me. So next for the Unreal Cloud DDC, again, this is an experimental status, which is kind of interesting. On one perspective, it's not experimental because we've been using internally on our projects at Epic. Fortnite uses this. We also use it on the Matrix Awakens experience. So in many ways, all of these features you see listed in 5.1, as well as the fact that we've been using internally and have shipped projects on it, it's not experimental from that perspective. However, the setup process right now isn't quite where we want it to be. We want to give a lot more of a turnkey solution to our licensees that want to turn this on for their projects, and it's not quite there yet. So kind of what's next on our roadmap here is just making sure that we really kind of double down on that setup experience and take those findings that we got from the coalition to really tighten that process up, as well as we talked about working with other cloud providers to provide solutions in the marketplace so that you could choose the best cloud provider for your projects. And under consideration here, we had a few other ideas that are a little bit further out, but just to give you an idea of some things we're thinking about. This can evolve from being just the Unreal Cloud DDC to being kind of more than that and being more of a general purpose storage. So things like having build results that are happening on the build farm, having those intermediate results being stored onto a system like this one, as well as maybe one day if we split out texture builds and do remote texture building, we could have and store some of those inputs and outputs also in a system like this. So those are definitely things that are under consideration. And again, we'd love to hear your feedback if you have thoughts on these topics. So with that, I want to give a big thank you to Phil and the team over at the Coalition. Like, your feedback and that collaboration we have going has been so helpful for our team to help shape what we're going to do next. I also wanted to do a quick shout out for Paul Chipchase, who's one of our lead programmers on virtual assets. He couldn't make it out today, but I'm sure he's on the live stream watching us. So thank you so much, everyone, for your time today and joining us.